Hello, everybody. Welcome to our webinar for the month. We're really excited to have a special guest speaker today, and I think you're going to find this conversation really interesting. Ed Burns is our guest, and he's going to talk about how he integrates simulation into the classroom. If we can go just one slide. Ed has a lot of experience with using simulation in the classroom, as well as using lean and simulation and a lot of the other process management tools in practice as well. He teaches at the University of Toronto, as well as teaches in the MBA program as an adjunct professor in operations management, and has a lot of experience using these tools from a practical standpoint before he started coming back into the university to teach as well. He does a lot of really interesting work with a broad range of organizations and across many, many industries. And so he's got a really interesting perspective on how we can integrate these tools together and how he teaches them. I'm going to let him speak more about his actual experience, and as we get into the conversation, you'll hear some great stories.
Okay, thanks, Brittany. Hope everyone can hear me there. Yeah, what I do at the University of Toronto is I'm a lead instructor for the course in business process management, and what that course consists of is three courses. First course is Foundations, which is just basics. Second course is one I teach, which is Tools and Techniques of Business Process Management, where we feature Simulate as a big chunk of that course. And then finally, the third course is Org Aspects, where we look at the soft aspects of business process change. I've been teaching the MBA programs at both Rotman and Schulich for, I don't know, probably 10 years now. And I'm also an adjunct prof in operations management at Schulich School of Business. I've got a ton of experience in both operations and in business, blue chip experience, most of it, high-level leadership level experience. I've been a CEO of a manufacturing company when we had those things, and also a vice president in a global engineering services corporation.
Great.
So, Brittany, do you want to jump in, talk about the agenda?
Yeah, I just want to give a little bit of perspective on the way we're going to structure today's conversation. So Ed's really going to take us through this first couple of sections, and then we're going to open it up and have more of a conversation around how he teaches and his approaches and what he's found, lessons learned, things of that sort. So I have some questions that I have for him that I think are really going to bring out some great stories you're going to find interesting. But also, please do notice that on your right side of your screen you have a chat window. If you want to share any thoughts or you have any questions for Ed, please do put them in. We'll aggregate those and then make sure that we get to them at the end of the session. And we'll also post any that we don't have time to answer up on our LinkedIn group for Simulate Healthcare. So definitely take a few minutes, take some notes, and share any questions that you have for Ed, and we'll get those answered for you. Just a programming note on your next slide here. We are doing the webinar. We are recording it, and it will be available for review and to take a look at it, share with colleagues at simulatehealthcare.com, so definitely go check that out when you have a chance. Also, just to note, you are on mute, so we will not be able to hear anything that you're saying, so that's why that chat panel is very important to use. Okay, Ed, well, with that said, the floor is yours.
Okay, great, thanks. Thanks, Brittany. I'll try not to scare everybody. Okay, so just to pick it out, we talked about those three components: foundations, tools and techniques is where Simulate really comes into play big time, and finally the organizational aspects of business process management. And organizational pieces, the soft pieces, are equally as important as any of the course the foundations pieces and the tools and techniques. Very often the hardest thing is to just get started, and the third course talks kind of a bit about that, a lot about that. This is who we typically get. I'm in the faculty of continuing ed, which actually is one of the largest faculties at U of T, which is a very large school. And to give you an idea of the scale, current enrollment is 24,000. And typically, that's just in this faculty of continuing ed, so it is an enormous operation. Typically, we get middle-level career managers, and we do a lot of kind of building block courses like project management, business analysis, business analysis, financial analysis, CFA, CA, CPA, all those kinds of programs. We do a lot of IT-type, IT-specific programs too, and operationally we do all kinds of different things, including Lean Six Sigma, and over the last 2-3 years we've developed business process management as a very viable course. We typically get, because it's continuing ed, we typically get mid-level career folks. The typical person is someone we get who already has a day job, and they're looking to upgrade their skills. That's very typical. So we get a lot of operations managers, we get a lot of process managers, we get business types, we get process owners. We're now starting to see that job title more and more, which is great. Many different process improvement practitioners. Typically, we get Six Sigma, Lean Six Sigma, Agile, even there are some verticals still doing TQM. So we get all of those kind of folks up to Six Sigma black belts, and we've had Six Sigma black belts from some of the usual suspects through this program already, and they've all found it extremely useful. We get a lot of people from IT. Typically the reason why we get people from IT is they have a very IT perspective on process, and they're finding that it's not perhaps panning out as they would like. So typically, and the way the course is written up, and it's all on the internet, it attracts a lot of people who want to broaden their sort of IT perspective into more of an operational and business perspective, and sensitize them to the sort of the issues, operational and business and people issues that come into play in process improvement. And the other, and also finally consultants. There's all kinds of different consultants. We get a lot of IT consultants, we get a lot of business consultants, some operations consultants, all kinds of varieties. So it's a pretty diverse group. Typically the verticals, because it's downtown Toronto and it's St. George, that's the faculty is called St. George. We get a lot of folks from financial services, we get a lot of folks from healthcare, we get a lot of folks from the IT shops, hardware. Well, there's not many hardware places left now, but software certainly, and a lot of folks from sort of big Fortune 100 corporations all the way down to little mom and pop shops. So we pretty much get everything in this course. So because it's U of T and it's an attractive kind of name and all that good kind of stuff, we tend to get a lot of different folks. So now I think we were going to throw this open to the audience and just say, where did you learn process analysis? 1, on the job. 2, professional courses. 4, did you self-teach it? I have to say I'm probably a bunch of 4, and I guess you could say someone, and 5 other. So would anyone like to sort of volunteer how they learn how to analyze processes from an operational, business, and performance point of view? I'm not talking straight business analysis, which I mean, the conversion of a manual process into a computer process. I mean actual analyzing process, like what it does and how it does it and how well it does it. So I'll wait for a response.
Yeah, so just a reminder for those who may not have seen us do a poll before, go ahead and select one, whichever one is most relevant for you. We'll aggregate the results in just a few seconds here, and then share them back, and then kind of take a look at who's on the call with us today and kind of where you learned it. It's always interesting to
do I get a vote too? Can I vote?
No, unfortunately not.
Hey, come on. It's the internet, right? The world is flat. It's democratic.
Yeah, this is true, except today.
Except for today. And yeah, I know that logic.
Okay. So let's see. Interesting. Wow. So clearly we have a strong section here. Not a lot of people coming through official courses,
Yeah,
through college or through the professional. So
that doesn't surprise me at all.
Yeah, a lot of learning on the job.
Yeah, yeah.
And how do you think that affects the way people approach process analysis and the kind of tools that they use? I mean, you're learning on the job. Do you think you get the kind of depth that you're teaching in these kind of courses, or how do you think that plays in?
No. I was kind of lucky because I was fortunate. One of my bigger roles where I led an internal operations performance improvement group for a Fortune 100 type corporation, and I had the opportunity. I was fortunate enough to be exposed to hundreds and hundreds and hundreds and hundreds of different operational improvement and business improvement process, and every single one had a process analysis component, every one. So I sort of learned it by sort of doing it, and I was just lucky that I got exposed to so many different ways of looking at process and so many different ways to crunch numbers on process. And probably like most of the participants, like there was no structure or there was no organized way I sort of learned it. I just sort of picked it up by doing it. And in fact, so when you do it that way, the problem with it is you're missing pieces. And the problem with it is you're spending a lot of time and intellectual energy reinventing the wheel. A lot of what you're experiencing on the day-to-day, people have already gone through and kind of codified and structured and organized, and that's what we tried to do in this U of T course in BPM. So stuff you learn, you could learn a heck of a, if you self-taught it, you'll do it wrong, guaranteed. I did it wrong tons of times. But by doing it wrong, assuming you survive, which obviously I did, but sometimes you only learn it by doing it wrong, and that's not the best way to do it, really, is it? So that would be my comment really there.
Yeah, it's quite interesting, and I wonder if I think we've identified a new market opportunity for you, Ed, to grow your course, because it's it's fascinating that I mean, I'll be honest, when we wrote the question, I was not expecting that to be the biggest segment of the answer. So
I was.
interesting.
Yeah.
Well, see, you're smarter than I am. This is why you're the guest.
No, not necessarily. No, I don't think so. I mean.
All right. Thanks, Ed. Go ahead.
You want to go? Okay, great. Yeah. All right, so next. And part of it, and it connects with the previous stories, the reason why that is so, what is built into Simulate, whether you realize it or not, and 99% of the folks who use it don't, it's founded on queuing theory. Now, queuing theory, I got to tell you, if you think Six Sigma was difficult, mathematically, queuing theory is the next step up. So I was fortunate enough that I was given the opportunity to teach queuing theory to the MBA programs here at Rotman. And that's where I actually learned queuing theory, like the theoretical framework for it. I sort of knew, like as an operations manager, I sort of knew it was there. I sort of knew what I saw, but I didn't realize that there was a whole body of theory that actually explains it. The problem is, and the problem why so many courses, but so few people learn this through formal channels, is that not many people teach it. And the reason why not many people teach it, it is perceived to be at the very high end of mathematical difficulty, and I am talking MBA students here at a school that is sort of renowned for analytics. So if those guys have problems, how does everyone else make out? So I wanted to include, like, I knew, like, who hasn't queued for a service? Like, nobody. And in fact, queuing and its associated relationship to capacity, organizational capacity and process capacity, is one of the big underappreciated, unsung issues in the whole thing. So I wanted to do it. I knew if I was going to do a course in process management, it had to involve queuing, but I didn't want to do the theory because it's just too much. So guess what? That's what Simulate does. And you don't need to do all that master's level statistical analysis and beyond. You can just do it. It's already built into Simulate, and I know it is because I've already tested it against the theory, and it does square exactly. So the reason why we included it was I didn't just want to talk about process. I wanted to give people a process, and unfortunately, the academic budget at the university, like most other academic budgets at the university, didn't allow me to hire half a dozen people and sit them in front of the class and start them processing things and have people look at what went on. In fact, that was my original thinking was to get a bunch of the class, sit them down in a process and have them work on it and then throw problems at it and see what it did. So unfortunately, I didn't want to do that. It's also kind of messy. Sometimes it worked, sometimes it didn't. That problem was totally solved using Simulate. So we could build instead of hiring 6 people and have them sit in front of the class doing a process, I could actually achieve exactly the same results in the digital world by using Simulate. And with Simulate, you get the power of queuing theory, which is very powerful, without having to do the math, which is great. So that's kind of where I ended up using where and why I kind of used Simulate. Most people who try to do process analysis don't have that queuing theory background. It is an important component. If you don't believe me, buy a textbook in queuing theory, open it, and I pretty much guarantee you'll put it down with it after about 5 seconds.
Ed, can I just jump in and share a story real quick? So I was actually speaking to a gentleman yesterday who is interested in simulation because his daughter is now studying industrial engineering, and
Yeah.
she has gotten interested in simulation, and so she's been sharing with him, and he's now really engaged with it. And he was telling me that he was amazed at how quickly she picked up, echoing the same message you just had. She has really picked up simulation and been able to use Simulate to land an internship actually for the summer, even though she has zero interest in programming and is not, as he described her, not a techie person.
Right.
Really a great message that I think we don't talk about enough is that we can really solve a lot of these problems without the heavy mathematics. So anyway, just wanted to echo your message.
No, and that's great. And the other reason I like Simulate is it's very Visio-like in its look and its structure. And most people doing process analysis or process management or process improvement usually have a Visio flowchart in there somewhere, and it just looks, so it looks familiar, and you don't have to be super mathematical to get it going. We have had people do very well in this course with backgrounds in law, legal services, HR, marketing. Oh, far be it for me to pass comment on marketing, but yeah, we've had people from sort of engineering, non-IT, non-technical, non-mathematical backgrounds who've used it very successessly. From a standing base. So yeah, exactly, Brittany. I mean, that's it. It makes it user friendly. It makes it doable. As I said, if you actually looked at the formulas and the theory behind actually what Simulate does, I can pretty much guarantee you just put it down. You just say, forget it. It's too complicated. I don't even get it. So why add simulation? Yeah, I actually at Schulich, we use a lot of Harvard cases, operations management cases, and what I did was I took a Harvard an HBS case and built it in Simulate, and even though that case had been taught probably for 5 years, it involves baking cookies, not too complicated. I was actually able to give the chair in operations some completely new insights that they actually hadn't got. That's even after teaching this thing for several years. And that's not a complicated process. Baking cookies is not a complicated process. Yeah, you can get insights. The power of Simulate is such that you can get things from it that you just don't get. You just won't see. You won't see the stuff that you could see once you start trying to model and simulate. You'll get insights. And a lot of, actually, funnily enough, I've actually found using Simulate, obviously, has increased my knowledge of process. Like, because I build a process and think, well, I think I know. I've got a lot of experience. I think I know what's going to happen. And then you build it, and then you run it, and then something happens that you didn't expect, and then you ask, why is that? And then you suddenly realize that you didn't understand as much as you thought you did, and all the time it's this back and forth between practice and theory, and they're both kind of leveraging each other up to increase your overall insight and understanding of the process. So it's accessible, it's very visually appealing, and power and speed. I think, I said before, we get people, even with some of the very diverse backgrounds that we get, so they're not all techies by any means. In fact, most of them are not techies. Really the power and the speed is a big piece. We can build a process, run it and test it in 40 minutes now, 40 minutes, and everyone walks away with a working Simulate process. And that 40 minutes basically replicates what it takes me 6 weeks in class to teach and what people spend 6 weeks doing. So they get the power and speed and the what if straight away. Wow, you know, what if we do this? What if we change that? What if we add this? What if we take that away? What if we add a step? What if we share a resource? All those like million what if type questions. It's perfect for that. So yeah, what I do is I sort of, one of the big things about Simulate, especially because, again, you know, the age we live in, people tend to think that the problems are solved by pushing buttons. And pushing buttons is no use unless you understand what the buttons actually do and how they do it. So what we do is we start from a very basic process map. So I describe a process, a couple of page written sort of case study, sort of wanders and meanders around, as any of you who actually tried to catch a process know. Often the biggest first step is just figuring out what the process actually is, and you'll find that's not always an easy answer to come up with. But assuming you can get past that, I sort of write a meandering, you know, process description with sort of a bunch of red herrings in, and people kind of navigate the way through that, and so they end up with a Visio flowchart. So that's kind of what they're doing. Most people doing process analysis, process improvement, usually get as far as the Visio flowchart. And then what we do, and then the big step, and the big step that makes Simulate work is adding those process parameters. So simulate the timing, which is the same as me coming from the theoretical background as process time, and the timing on the arrival rate or the inter-arrival times. Again, that's sort of a little peek at theory. Don't worry, nobody understands inter-arrival times. Then you just add the process parameters, and then what we do is the first 6 weeks of the course, I make them analyze the process kind of old school in Excel, so that they sort of understand what the process does before we start Simulate. We sort of understand what it performs at. We understand how long it takes, what's the total flow time. We understand what the work in process level should be. We understand what the capacity is, where the bottleneck is. So we start to understand all of those kinds of things based in a purely static process. So a fixed arrival rate, or workload, or workflow, some people call it, and a fixed processing rate. So what we do is we build that in, and I make them grind through it. And that's why I withhold Simulate until module 6 or 7. Because I know if I put it out there, let the class access it, everyone would jump on buttons and start pressing buttons and spend a ton of time, waste a ton of time getting crazy results. But doing it this way, people sort of know what the process should do. So we build the process in Simulate. I do it live. I just throw it up on the screen, on the projector, and I have everyone build the process with me. And they fall into all the usual traps, and we work those through. And it's very fast and it's very easy. And I say less than for 40 minutes is our record. But then what we do is a key step is we reconcile, we see what we got from Simulate and compare it with our static results. And if I've done my job and everyone else has done this, everyone else has done it properly, you get exactly the same results. So we test the process first, test the Simulate model first, and we already kind of know it works. So it's starting to produce results that jive with our reality and with what we know. And then we do the big thing, which is add the variability. And again, like a lot of things, like People think they understand process capacity, but they don't. People think they understand bottlenecks, but they don't. People think they understand variability, but they don't. I didn't. And I come from that world. I thought I understood variability, actually, until I started using Simulate and until I actually started digging back into those. And I actually reread a lot of those old stat theory textbooks. And when you read them as a mature adult, not in school, it's funny you do. Well, I use mature adult kind of loosely. You do get a bit of a different insight, and that's something that you can't do in Excel. And the beauty is, say, we do that in 40 minutes, and people are just blown away that in 40 minutes you could do something that took us 6 weeks, and actually more, because we couldn't do the variability. We don't attempt variability doing it old school manually in Excel. I know you can, but it just takes too long. So that's what Simulate does for people, and most people are really. I mean, most of the time it's like, wow, that's interesting. I didn't know that. Yeah, and just to echo my points, the problem with process simulation isn't connected with process simulation. And most process professionals and IT folks, and that includes those Six Sigma black belts from the usual suspects. They think they understand it, but actually they don't. And there's a lot of operational pieces of process that are embedded and encoded and already built into Simulate that people think they know, but they actually don't. And like I'll use this quote from Yogi Berra, my favorite management writer. It's not what no, actually that's, did I use the wrong one? I misquoted him. I picked the earlier version. Okay. Sorry, it's Yogi Berra, so I'm allowed to misquote him since he pretty much misquoted himself pretty much all the time anyway. So this is like a real live demonstration of Yogi Berra thing. Anyway, so it's not what you knows you don't know is the problem. It's what you thinks you knows but you don't. And I'll give you an example of well, I should generalize it to avoid protect the names of the not so innocent. An IT director at U of T, so that basically is a pool of about 20. So IT director at U of T. As soon as he learned I was using this, this is great. I'm going to use this on our school enrollment process. Well, very good application of process simulation, actually. So great. Come back and tell me how it worked. Comes back to me 2 weeks later. Doesn't work. I said, what do you mean doesn't work? I said, I can't. It doesn't run. I can't. It gives me crazy results. I said, no, it doesn't. And so let's go through the process. And so what it turned out was, again, he didn't understand the process to the level at which you could then proceed to model it. There were things going on in the process which he thought he understood, but he didn't. And that's the beauty of using Simulate, because if the process is as described, if the process operates as described, if the process has the parameters process as described, you should be able to model it pretty accurately in Simulate. If your Simulate results don't agree, then 9 times out of 10, I will bet it's because the stuff going, the way the process actually operates is not what you were told. There are things going on in the process that you don't know. And there are a variety of things that can go on, and we talked about those in the course. But it's not what you know you don't know. It's what you think you knows, but you don't. My apologies to Yogi Berra for mangling him, but since he mangled everyone else, I guess that's acceptable. So start with a simple process. And the important thing is to learn the fundamentals. And people think they understand fundamentals, but actually they actually sort of don't. And so you've got to have those before you can use it. You've got to have a process working and generating results, and you've got to validate and test before you start to really build towards more complexity. So once you've built the process, run it, tested it, got believable results, then you can start adding complexity. Then you can start running what-ifs. Then you can start messing with it and seeing what it does. So that's kind of the lessons we've learned. I know, for instance, if I gave the case study as is to the course and told them to build the model in Simulate, I'll bet 99% of the people couldn't do it. And again, it's because what they think they knows, but they don't. So that's that. And yeah, so that's sort of the main piece for me. Did Brittany, did anyone want to comment on anything?
Yeah, so let me just jump in. We've had a couple questions come in. I've also got a couple that I want to ask myself, and actually, I want to go back to the point that you made earlier about teaching to a wide range of people, and there's a couple questions around that.
Yeah.
The first was, how do you persuade people who think this is, quote, too techie, that it's safe to approach and safe to try to teach to kind of the non-nerdy types?
Right. Well, what I teach them is, I think it's, I teach them these process fundamentals. Is the Simulate takes care of the techie piece. You don't need the techie piece with Simulate. You don't need that queuing theory, math, stat background to do this. So really, what you've got to do, if you can understand the fundamentals and build the process model just to start in Excel, you understand enough about that, then really moving to Simulate is a no-brainer. It really is. So that's how I do it. So it's the problem is people don't, when you say it's techie, no, it's not. If you can draw a Visio flowchart, you can use Simulate. That's pretty much it. The so-called techie bits aren't techie bits at all. They're just understanding process fundamentals. That's not the techie bit.
I would agree with you, actually. It's interesting to hear how you phrase that, though. So kind of a follow-on question to that, if you have a classroom full of folks who have different skill sets, different industries, different comfort levels, how do you approach kind of managing all of that different kind of starting point in your class and making sure that even though people are going to work at different paces, they all are able to end up kind of with the same depth of understanding of some of the tools you're teaching? Not
Right.
just Simulate, but others as well.
Right, and that's that's actually an excellent point, Brittany, because we literally have had people in this course, in the same class, we've had vice presidents of IT from Fortune 100 corporations sitting next to code-level program people just starting out with a year or two's experience, purely back-office programming work. We do get an enormous diversity. How I teach it is actually interesting. We create project teams, and when we create a project team, because the project, the in-class project, the case study is actually not done individually, it's done as a project team. And when we put the project teams together, we pretty much try to ensure, it doesn't always work, it's not perfect, but we try to ensure a good mix of people, right? So every project team kind of there'll be one IT person, there'll be one business person, there'll be one operations person, there'll be one consultant, there'll be one, Six Sigma black belt or whatever. So we try and get a mix of people, and so they work as a team. And so what happens is, outside of the formal instruction and the support that I provide, which is a heck of a lot, they can kind of work on their own in the corner with their little team. And in that team, you can pretty much guarantee that there's one person who understands, each person will understand a piece of it. And few people will understand all of it. But by working as a team, they can kind of talk and, oh, hey, now, this is what you do. Oh, I didn't know that. So, okay, oh, I didn't know it works that way. So that's how I found it. That really helps too. And that's a kind of a whole additional thing that goes on. And that, by the way, is we really like to do things like that with teams, because that typically is how people work back in the real world.
Yeah, it's always good to get back to the real world.
Yeah.
That makes me think, and I'm just thinking out loud a bit here, but you're talking about professionally, people have different backgrounds, different levels of experience, different kind of perspectives.
Yeah.
Would you say that you could apply that same team concept to developing undergraduate or master's programs? If you could take some engineering students, you could take some business students, you could take some social work students, throw them all in the same room and work that process?
Yeah. Thank you for mentioning that. Yeah, believe it or not, yes, we have had a number of people already from social service, public agencies, and various levels of government at all, federal, provincial, and municipal. And we have had those kinds of people through already. And yeah, it's completely doable.
Cool. I think we've got some more projects in front of us here. I'll work on some more case studies. So let's take it back up a level, kind of more strategic. How many people have you had through the program? How is that growing, I believe, and can you kind of tell us a little bit more about what your kind of vision is for how you want to develop the program?
Yeah, it is growing. What's happening is because we put this under the moniker or under the heading of BPM, rightly or wrongly, that's what the university wanted us to do, which is fine. We're getting good. We are getting actually pretty good growth, especially with the online program. One of the things that's happening is most organizations, a lot of them in the verticals that we're in the downtown GTA, are sort of coming out of or exiting Six Sigma. Having been through that and having had decidedly mixed success and or no success at all with Six Sigma, and they're sort of currently in the sort of now Lean Six Sigma, and we have courses for that. But what we find is that BPM is slowly getting traction as people are coming out of Six Sigma and Lean Six Sigma and saying, well, what next is there? Oh, that didn't work as well as we'd like. What else can we try? So we're starting to pick up, and in fact, in the school, we actually get a lot of people back and forth between BPM and Six Sigma and Lean Six Sigma. We get a lot of cross-fertilization between those programs. People do both and found them completely complementary. Is that there's very little that we do in BPM, or I should rephrase that, pretty much everything we do in BPM is not duplicated in Lean Six Sigma or Six Sigma. So it's a bit of a different take on process. And people are starting to get it, and we're starting to see growth, more use of the term business process management, and that's kind of what's kind of happening to us. So we're at the early stages of a growth curve. I think what's going to happen is eventually, I think BPM will probably take over. And so it's because the way we teach BPM is a bit more holistic. than typically most of the sort of the Six Sigma or Lean Six Sigma approaches. So yeah, we're definitely on a growth curve. Our enrollment's been pretty much building every year. We're now at a couple of hundred people every year through this program.
Wow, that's phenomenal. It is interesting to hear you say that you think the transition in kind of terminology and in approaches is transitioning towards BPM, and that it's fundamentally a different approach than the kind of Lean Six Sigma tool set. So I'll have to maybe come back to that at some point and talk about that a little bit more.
Yeah. A lot of people think, especially if they're like a Six Sigma black belt, they think, what am I going to learn? And what they realize is it's a bit of a, like BPM is a completely different approach. And the reason why organizations are like it is because you can roll it out without, it's simpler to understand, it's easy, it's not complicated. You explain this to any operational and business manager, they get it right away, and so you don't have to do a lot of fancy dandy, stats. And to me, using, simulate just is like, is the kicker, is the real icing in the cake. So it really like puts that on roller skates, puts that on steroids, right? So yeah, it just helps the whole thing.
Awesome. So I think you also said when we were talking before we started today that you've been doing online courses and that you've started to roll out some new videos and some different formats. How does that work, and how successful has that been?
Great. The last one I did, which was not perfect, got an evaluation of a 4.9 out of 5 points on the university's 5-point evaluation scale, which is, I believe, is one of the highest, if not the highest, evaluation ever for an online course in the faculty. It's a good fit. It's a nice fit. Again, part of the thing is the technology that the university has been deploying has sort of been changing under us a little bit, but we've been trying to take advantage of it. And we've just on this iteration, as of 2 weeks ago, we're putting the course up using Camtasia, which basically, you may not know, folks, but it's basically makes a video of your class and then converts. You can use a PowerPoint slide, so you can deliver a narrative over the PowerPoint, and then it records that. And then it's converted into a Flash MP3 file, so then it's readable on the IT tells me any device, or pretty much any device, and it's just like YouTube. So it's kind of like it's become like a YouTube course, and that's where it's going. And I'm not quite there yet. I'll be there in March, but and people really like it. And what I'm going to do is I'm going to run, once we get into the simulate piece, I'm going to be able to run. Make like a YouTube video of applying simulate to the case study, and yeah, people the online, it's going really well. This being able to make these videos, I think moved it up a level as well.
Interesting. So, are most of your folks coming from the Toronto area? Or are you starting to see? Or, I mean, in an online platform, you could really be anywhere.
Yeah, the last class I had somebody from Singapore, had a bunch of guys from the States. Although ironically, what we actually find is that 90% of enrollment is from the Greater Toronto area, and in fact, I've got one online person who, according to their online information, literally lives across the street from the university. And it isn't a geographical thing. It's usually a time thing, right? It's a schedule thing. It's a time thing. Even people in the GTA. I mean, the traffic here is so bad that people just can't make it down in time for class. And of course in winter we have the additional issue of snowstorms and what you're getting in the US East Coast right now. So we have all of that too. So certainly, online is becoming a very popular option. In fact, I think I just crunched some numbers on Monday, and in fact 2/3 of our enrollment now is online for this course, the certificate.
Wow, that's phenomenal.
Yeah.
That is really incredible. Totally turning the concept of professional education kind of upside down. Moving from the kind of, after work, I drive over and I eat dinner in my car and get there at 6 o'clock and sit there for 2 hours, and, now I can do it anytime I want on a Saturday afternoon or kind of at my own convenience.
That's right. Yeah. I mean, that's why it is so popular. And in fact, the university is telling us that they believe within the next 5 years that 80% of what they do will be online.
Wow. Wow,
yeah.
That is phenomenal. And really, actually, great for us as a community of folks who are interested in process improvement in all of its forms, right? Lean, Six Sigma, BPM, whatever terminology you want to use.
Yeah.
That we can really reach folks in Singapore, like you said, with the same messages and really flattening that playing field.
Yeah.
Phenomenal. Cool. So last couple of questions here. We've just got about 5 minutes left or so. Got a couple of questions about how you actually design homeworks and the case study itself. What kind of principles do you use? I mean, you talked a little bit about writing the narrative that's rambling and kind of disoriented
right.
to replicate reality. But would you mind sharing some of the details of that?
Sure. Well, it sort of describes the process at a high level. Describes the activities that people do, the time that people take, the workflow. It describes some of the issues. For instance, the vice president that approves the loan in this case, is only available for a certain time, Friday afternoon, or takes 20. I have different variants. Each class I do a different one, so they can't copy it. They can't copy it from the previous class. So I changed the process parameters. There's a whole bunch of process parameters I changed just for the heck of it. And so there are things that are like things going on. There are like delays. There's availability issues. People aren't there for whatever reason, and all that typical kind of process stuff. There's a big bottleneck. There's a situation where management go around assigning more work and more work and more work into the process, like creating work, adding it into the process, and somehow seem to think that the process will continue to operate as before, and they won't kind of connect the dots together. And there's a couple of different bottlenecks. There's a bottleneck which you first think is the bottleneck, but actually really isn't the bottleneck. And then there's also, because it's only when you look at the process in total that you realize there's actually another bottleneck. And that, again, replicates reality. The true bottleneck isn't always the one that seems to be the most obvious. And also, secondly, what's big is there's delays everywhere. There's delays all over the process. And one of the fundamental big learning takeaways, again, one of these process pieces that people think they know but they don't, is that delay does not affect process capacity. And most people don't know that. Even process managers with tons of experience don't know that. And again, that's what Hughes thinks, Hughes knows, but Hughes don't.
Absolutely. Do you would you mind showing us kind of what your process map looks like? Just kind
Oh,
of get
okay,
a feel
sure.
for.
Yeah, sure, absolutely. So let's just end this. Yeah, I mean the thing is, it's very simple. I'll just got to throw out the Visio here. It's really very simple. It's a commercial lending process. That's just the one I'm using right now, which is easiest to hand. And basically there are a number of positions. So there are a number of people. There are a number of departments. There's lots of handoffs. There's delays. And so you can see it's not very complicated. I mean, anyone listening, the audience listening on this, I'm pretty sure that most of your processes probably have more steps in that. But that's basically what we build. We build the model in, and I think that's how that's the basis of the model, and learners first have to construct that, and most people don't have a problem constructing the flowchart. And then what we do is we take the next step, which is to add all the process timings. So it really reinforces how easy it is to take what you're already doing, which is Visio flowcharting and Visio process mapping, how easy it is to take that and then build, with Simulate, build process analysis, a comprehensive approach to analyzing the process. Because the only difference between this and Simulate is that the timings on here, and that's what we do.
Awesome. Cool. Well, thank you for sharing that. We
Yeah.
are pretty much out of time, so
Yeah.
if you'll just pull up the PowerPoint again, we want to share a couple of last thoughts. So, this was a really great conversation, and I know I'm excited to hear a lot of our attendees' thoughts about, how they can incorporate this into their own work, and looking forward to sharing this with a lot of our educators who are using Simulate already, and then kind of getting their feedback as well, and see if there's other kind of lessons learned that we can pull together. But in the meantime, we just wanted to mention to everybody, and there'll be more information coming out soon, that they should keep May 19th on their calendars. We'll be downtown Toronto with Ed and myself. We're going to lead a process management redesign one-day seminar talking about some more of these tools in depth, talking about some actual case studies where people have been successful incorporating these concepts into their process management. And so we'll get into a lot of this in greater detail in May. So that's going to be really exciting. It's going to be healthcare specific examples and content. And so just keep that in mind, put it on your calendar, and we'll get sign-ups going shortly. Great. Anything else? I think there's one more slide just to mention it to everybody. Reminder that this recording will be available on simulatehealthcare.com. And if you have any thoughts, questions, you want to suggest either a case study that you have worked on yourself, or somebody who's doing some really interesting work and would be interested in guest presenting like Ed has today, we would love to have you. You can contact me at brittany.h@simulate.com. And we'll look forward to hearing from you guys. Thanks so much, Ed. We really appreciate you taking the time, and we will look forward to hearing from you again in May.
Yeah, will do. Thanks so much for listening.